defined by using these two formulas. Right? Interesting? So this is centripetal force. The way we compute centripetal force in physics, and even the way we compute centripetal force in chemistry. Interesting. I like the relationship between physics and chemistry, because simplify life. So then I want to take you into the force, Bohr's, postulates. So we say that the force, Bohr's assumption. Okay? If you are watching this material in a group of 2 or more than 2 students, please look the face of your neighbor. Is he or she smiling? Okay, so tell me in the comment that what happens when you have been watching together in the school computer or by using an electronic device. The first Bohr's assumption is still relating to the third, right? The third assumption. And this say that, he said, the angular momentum, let me underline this keyword, very important word, of the electrons, because electrons is orbiting the nucleus of the electron, right? The angular momentums of the electrons in the stationary orbit, or in the stationary states, especially that ground state, okay, especially at the ground state, because electrons, the dwelling place of electrons, or the dwellings, energy level of electrons is what is the groundy level. So is quantized. Is what is quantized. And it is an integral. It is an integral multiple. It's an integral multiple. It's an integral multiple of what? Of Planck's constant over 2 pi. That's right the way it is. I will explain in a very simple language. Where, yes, okay, at the first Bohr's assumptions. Remember I told you that I will teach you 5. So the angular momentums of electrons in the stationary orbit or ground state is quantized. And it is an integral multiple of 40 Planck's constant and 2 pi. The angular momentum of 40 of electrons here, right? The electrons is orbiting the nucleus, right? It's orbiting the nucleus in this direction. So when electrons is describing the circular motions, it's not moving linearly. Its distance we call it angular displacement. Its velocity we call it angular velocity. Its acceleration we call it angular acceleration. Of its accelerating is angular deceleration. Then its momentum we call it angular momentum, not linear momentum. And also its force we call it torque, right? So the angular momentum of electrons are describing this circular orbit. In the stationary orbit, for example, suppose that this is a ground state. What does it mean? For example, suppose that this is the nucleus of an atom, and then we represent the energy level. So suppose that this is ground state. You know the names? Do you remember the names of ground state? Yes, I told you. We call it the Lyman series, because this is a spectrum. Remember I told you about different types of spectrums. Suppose that the ground state, and then we have electrons that is revolving in this circular orbit. So then we say that the angular momentum of electrons here, which you use this symbol L, is equal to Planck's constant over 2 pi. So it determined the numerical value of 40 angular momentum. So L stands for what? For angular momentum. I told you in the emission analysis, refined. Right? But again, when he did a further experiment, he said that it's an integral multiple of 40 of h. So in chemistry, we said that let the integral, so there's another integral multiple. Let the integral multiple to be what? To be n, whereby n is equal to 1, 2, 3, 4. This we call them in mathematics counting numbers, right? So then, if that's the case now, the first Bohr's atomic assumption, we can write it like this. So mathematically now, we say that angular momentum of what? Of members? No, of electrons. Okay, angular momentum of electrons, which is L, is equal to the integral multiple n times Planck's constant over twice pi. Right? So keep this formula for the rest of your life. You will find it in general chemistry, you will find it in modern physics, and it has been asked frequently. Okay? So from concepts of circular motions and rotational dynamics, we say that the formula for the angular momentum, we say that it is, because it's just like in case of linear momentum. Linear momentum, we say this is mass times velocity. Similarly, also in rotational and circular motion, instead of mass, we have what? Moment of inertia. And then this is what? This is angular times angular velocity. Okay? So that's the formula. So it means that is moment of inertia times what? Angular velocity. But moment of inertia of the body should be mass times radius square times what? Angular velocity. Right? So that's the case. So it means that angular momentum from the rotation or from the physics perspective, this is given as moment of inertia times what? Angular velocity. Right? Then we say that, but the formula for the moment of inertia from physics perspective is mass times radius square. So we say that the angular momentum now is equal to mass times radius square times what? Angular velocity. But again, I told you in the 30 assumptions of 40, in 30 Bohr's assumptions, that the linear velocity is equal to angular velocity times what? Radius. Right? So then we say angular velocity, for this case, is equal to mass, and then times radius times what? Angular velocity. So suppose that this is equation 1 and this is equation 2. Right? So then the angular momentum of electrons to be mass times the radius, okay, of the electron cycle, and then instead of this one we have linear velocity. So we say that the angular momentum in chemistry now, according to the Bohr's, we can find it by using moment of inertia times what? Angular velocity, or we can find it by using mass and then radius of the orbit times angular velocity, or we can find by using mass times radius times what? Linear velocity. So all of these formulas are formulas for angularity, velocity of 40 of electrons. Is it interesting? Yes, chemistry is beautiful. I told you before I began my session. Okay, remember that this is mass in kilograms, this is radius of the cycle in meter, this is angular velocity in radians per second, and this is linear velocity in meter per second, right? So in case you have any questions, don't hesitate yourself to ask in the comment section, right? And then don't forget to tell us you are watching this video from where. Tell us the place where you are, because we want to assess how far we have sent this message in our country and even in African continents and even in the world. So if you give a feedback, we'll be giving God thanks for what He has done and make sure that to bring this concept regardless of how far you are. Then let me finish these issues of assumptions. Let me give you the fifth Bohr's assumption. Okay? The fifth Bohr's assumption, which actually that is very interesting. He said that the electron, the electron can jump. The electron can jump from one energy level, from one orbit, okay, from one orbit to the other orbit. Okay? This is very important contributions of Bohr's to the other orbit. So electrons can jump from one orbit to another orbit, and when they do so when they jump, or when it jumps, because it's single, when it jumps from what? From one energy level, from one orbit, which you call the energy level, from one orbit to the other orbit, then it may either absorb, this is the very important keyword, or emit or radiate. Or emit, absorbs, or radiate. Radiate what? The energy. The energy. So before I explain to you when does electrons emit energy and when does electrons radiate an energy, I would like first of all to use diagrams, the energy levels, to explain these fifth Bohr's assumption. And then I will define, or I will teach you when does electrons emit or radiate or absorb energy. And then you will enjoy chemistry, advanced chemistry, like how I do, or even that more than me. So suppose that this is first energy level. We call it a Lyman series according to hydrogen spectrum. This is the nucleus of an atom. And then this is the splittings of one shell, for example, for the hydrogen atom. So this is n is equal to 3, n is equal to 4, etc., etc. So according to Bohr, when electrons will be in the ground state, this we call the ground state, or we call it Lyman series. So ground state, or we call it Lyman series. This is Balmer series. Okay, Balmer series. This is Bastian series. Okay, so what happened? Listen, I want to explain those two concepts. When electrons is in ground state and it has to absorb energy in order for these electrons to jump from the Lyman series to the Balmer series. Right? So that's absorption. Against if these electrons want to jump into the Bastian series to absorb energy also, right? And if it want to jump to the Bastian energy level, it has to absorb what? Energy. Even if these electrons want to jump from the ground state to the infinity regions, it has to absorb what energy, because this is infinity. So at infinity, it means n is equal to infinity, where ionization process used to take place. So it means that in these two cases, we say that under this, all of this one, we say that here electrons absorb what? Absorb energy. Right? When electrons is, for example, is in Bastian series, right? And then still wants to jump from the Bastian series to the Balmer series. It has to radiate or emit the energy it has absorbed to jump from Balmer to Bastian. So it does not emit or radiate something else. It emit what it has absorbed, because the resting place, or we say that the comfortable place for the electrons is always the ground state. So when the electrons didn't absorb any amount of energy, it will remain the ground state forever, right? But if you find electrons is in Bastian, means it has absorbed this amount of energy and excited it from what? From the ground state to the Bastian series. We call it excitation energy. So when again these electrons wants to jump to the Lyman or ground state, it has to emit electrons or radiate emit or radiate energy. So this case and this case, most of these cases, so you say that here electrons emits energy in form of what? In form of radiation. Right? In form of radiation. So that the means of what? Of the fifth Bohr's postulate. Right? So it means that we say that the process, let me add this concept to you, can help you. The process of electrons, or the tendency of electrons to jump from one orbit, according to Bohr's, or one energy level to the other, is called the excitation. So this is called what? Excitation. So that the meanings of that process. So when you'll be asked that define excitation, add the meaning. So this is the answer of the question, that what is excitation of electrons? Excitation of electrons. So I gave you the advantage. Okay? So we are still in lecture 6, lecture or session 6 of general chemistry. Then it's better for us to touch some few concepts on what? On the process of radiation and what? Radiations and the absorption. So we say that an electron absorb what? Electrons absorbs radiant energy radiance energy when jumps from the lower energy level to the higher energy level, as explained. For example, if these electrons want to move from the ground state to the Pascal series at this same energy level, then it has to absorb what? Radiant energy. That's one of the concepts that you have to understand. The second one, we say that an electron radiate or emit, radiates or emits what? Radiant energy. It is absorbed when jumps from what? When it jumps from what? From the higher energy level. The higher energy level to the lower energy level. The lower energy level. The lower energy level. So that's what I've explained. If electrons is in Pascal series, it has to jump. This is high energy levels. So the energy increases, lower energy level, higher energy level. So if it jumps from the Pascal series to the ground state, it has to absorb, it has to radiate the energy it has absorbed it. And if it jumps from the Pascal to the Balmer, it has also to radiate the energy that has absorbed it during the excitation process. So those are the few points that I wanted you to understand or to grasp. Again, we have a question we have to ask ourselves. What is the meaning? What is the meaning of what? What the meaning of the term? What the meanings of the term stationary? Stationary what? Stationary state. I gave a promise that we define, because this is the one of the phrase that we found in Bohr's atomic postulates. Then we say that, so it's a question mark, for define the stationary state, is any of several energy states, any of several energy state, any, whether it is lower energy state or several energy state or states, an atom may occupy without emitting electromagnetic. That an electron of an atom may occupy without may occupy without or without what? Without emitting electromagnetically, without emitting electromagnetic radiation. electromagnetic radiation. So it's any of the several energy states that an electrons of an atom may occupy without emitting electromagnetic radiation. That's the meaning of stationary state. For instance, for example, this is a ground state. This is the Bohr'S state. This is a partial state. This is the lower energy state. So you say that is any, not a particular, not only ground state is a stationary state. No, any, either this one. This is Bohr's, right? It may be, we call it a stationary state if an electron that's staying here does not emitting electromagnetic radiation. Also, when we have electrons in this bracket series, right? We call this bracket energy level the stationary state if electrons dwelling or electrons circulating or orbiting the nucleus of an atom does not radiate electromagnetic radiations. That's how we say that this is a stationary state. So it's any of these. Have you understood? Well, so in case you have questions, please don't just state yourself, ask in the comment section. So it may be ground state or excited state. So again, remember that. This is the ground state, but all of this, from the higher energy level to the secondary energy level, in chemistry, this we call the excited state. So this is the ground state, all of this one. Bohr'S series, Bastian series, bracket series, P-fan series, we call them sort of excited what? States. So these are excited states. So it means that the example of this stationary state, it can be ground state, or excited what? Excited state. Be ground state or excited state. Okay. Chemistry is beautiful. So, to end this lecture, I would like to teach you two advantages of Bohr's atomic model, and then give you the homework. You have to do it before we meet in lecture 7 of general chemistry. Right? So now you know a lot about Bohr's. Then the question is this: advantages. I want to teach you about advantages of Bohr's model. You know a lot about mathematical Bohr's atomic model. So you now many mathematical the assumptions of Bohr's, his experiment in his model. You know the stationary state, the excited state. You know the absorptions of energy, the radiations of energy. So you know all of them. So what are the advantages? So the questions you may be asked that you mention two advantages of Bohr's atomic model. Okay? So solution of this question or the answer. I will help you and I'll leave a homework for you. The first one, Bohr's atomic model was successful in explaining the first advantage. I said the Bohr's atomic model, right? The Bohr's atomic model was successful in explaining the spectra, means the spectra of hydrogen So in explaining the spectrum of 40 of hydrogen atom, okay, hydrogen atom or hydrogen ion. Hydrogen atom or ions consisting or ions, hydrogen's atom or ions consisting, so here we have continuation mark, consisting only, let me write it, this in capital letter, just to give you the key point. Only one electron. Only one electron. So it is limited for the ions or hydrogen's atom that consisting only one electron in its shell. In its what? In its shell. Right? So it means that these Bohr's models, his contributions, he's dead, but even now, in case you want to study about the spectra of hydrogen atom, we can start without referring the work of what of Bohr's. So example of the atoms that can be studied by these Bohr's atomic models is what? Hydrogen. And then the second example is lithium ion when it loses 2 electrons. Because lithium has how many electrons? 3 electrons. When it ionizes by receiving the first ionization energy and second ionization energy, in case of energetic, then it's forming lithium ion. So at this state, it has lost 2 electrons, it remains with only 1 electrons. So because it remains with only 1 electrons, then this structure is similar to what? Hydrogen. Right? So just listen carefully, and I will be asking a question there, and then you'll be surprised that why did I ask you that question? Or how did I know that it might be maybe a challenging question for you? So that's the first advantage. If we want to understand the structure of hydrogen atoms or ions consisting only 1 electrons in this shell, then we have to refer Bohr's atomic model. Is it interesting? I think you enjoy. For me, I enjoy. I would like just to keep on teaching you. I don't know about you. Possibly you are tired and then you are praying for me to end the lecture. Okay, don't worry. God will answer your prayer soon. Number 2, the second advantage. So the second advantage, we said it is true that nearly entire mass of an atom is concentrated in the nucleus. Rutherford it means that suggested about that. Thomson explained a little bit about that. So Bohr's now confirmed it is true that the mass of the electron, the mass of the atom is highly concentrated. Highly concentrated, right? Concentrated in the nucleus of an atom. The nucleus of what? Of an atom. It is true, okay, of an atom. Okay, so those are the 2 advantages of what? Of atomic model. So now this is a bad time for students who don't like chemistry, but it's a good time for students who like chemistry and who are ready to work on chemistry problem, because it's the time for homework. In every lecture, many of the lectures, I will be leaving the homework for you to do and test what you've understood and even what you can state or what you can relate. Okay. So this is homework 6. So homework 6 for lecture 6. I want to end this lecture. Okay, before I write the questions, I would like just to explain a little bit for you to give an assistance as your lovely teacher, okay? So, I've told you about assumptions. Those assumptions are, like we call them, Bohr's atomic models. They are theories. They are assumptions, but also they are theories. So sometimes in some of the books, they don't even call assumptions, they call them theories. So I've taught you how many Bohr's atomic theories? 5, right? So when I've taught you that the 5 Bohr's atomic theories, and then I told you the advantage. The advantage of these Bohr's atomic theories, they have been, it means that what he succeeded in to present even to our lifetime right now. So I taught you 2 advantages, what has been accepted. So now I want to ask you, repeat this lecture or watching this video several times as well as you can. And then I would like to give you a task that go and find the shortcomings of Bohr's atomic theory. Don't run to the internet or to the chemistry books and then copy and bring them to me. You'll be killing yourself, right? But sit down, meditate the lecture or the lecture or the session that I have been teaching you from the beginning to the end, and then think yourself, imagine like you are a Bohr's, or you are Bohr's, right? You are a chemistry Bohr's, and then you want now to correct him. Or imagine that you are a teacher of Bohr's, or you are you want to correct his models. So it means that whenever we find shortcomings, means that some of the chemists have given the evidences that what you have said or what you have observed is not true. So that's the work right now I want you, because this is lecture 60. My intentions, I would like to teach you think differently in chemistry problem. So now the homework is this one. Explain briefly, okay, briefly, the 7 shortcoming of Bohr's 7. This is 7. Don't say that the number was not visible. 7. Bohr's atomic models. Explain briefly the 7 shortcomings. Let me just write it correctly, because I know students, they used to have a lot of excuses. Lectures that, sir, the questions was not visible, that your handwriting was not readable, but he or she has been reading my handwriting from the beginnings of the lecture, but when it comes to the homework, there's a lot of excuses. The 7, and let me write just numerical, 7 shortcomings of what? Of Bohr atomic models. So I'm waiting that this is the end of lecture 6. I would like to thank God who have given me grace and power to teach all of this stuff. It wasn't easy during the preparation time. It is not even easy during the teaching time. But God is faithful. He gave me power. He gave me knowledge. He gave me understandings. I've tried my level best to teach you. In case you have questions, don't hesitate yourself to ask in the comment section. I would like to thank you for taking your time, and then make sure that you subscribe onto this YouTube channel. And it's a school, Tanzania Online A-Level Secondary Schools, Olenjolai. And make sure also you are not selfish. You share this material with your classmates, with your schoolmates, with your colleagues, with your young brothers, with somebody who you know that these materials will be helpful. Okay? Again, in case that you have been helped a lot with this program, well, I would like to invite you to join me in offering this Thanksgiving offering, because for me, I'm offering my Thanksgiving to God by teaching you. You have to pay a lot of money to get this stuff, but I'm offering to God through you. So even yourself, you can offer God through me in order to pay for the running cost of this program, so that nothing will be late, everything will be uploaded or will be transmitted to your place at the right time. So in case you want to do so, you use this number 0759 74 53 31 by using the M-Pesa. That the methodology that we have right now. The name the name that you have to confirm that it has to come is Olenjolai Tayai. Thank you very much. I love you. May God bless you. I'm praying for you. Please pray for me, for God to make sure that I do this business effectively at His own standard. But I don't deserve any glory or any praises on this. All the praises and all the glory has to be received by Almighty God. Goodbye. May God bless you. Thank you.